Okay, so this is problem number 14. We've got the scenario where we've got two carts. One is going to run into a spring, and it's going to take a half a second for that spring to stop. And then the other one, it's going to run just into a regular wall, and that takes a tenth of a second to stop. Same mass of the carts on each side with the same initial velocity. So to start off, let's just write what their initial momentum is. So 6 times 1.5 equals 9 kilogram meters per second. Here we have 0 kilogram meters per second because it stopped. Once again over here, this would be 9 kilogram meters per second and 0 kilogram meters per second. Okay, so we've just calculated the initial momentum of the carts. We can answer that. It'd be 9 kilogram meters per second. Next, we need to calculate the change in the momentum of the carts. So here, let's look at the momentum final minus momentum initial is going to equal 0 minus 9, which equals negative 9 kilogram meters per second. Which cart experienced the bigger change in momentum? It was the same for both. Which cart felt the bigger impulse? Well, in order to do that, we need to calculate the impulse for each cart. So if we take a look here, and remember that impulse is equal to change in momentum, but also equal to force through time. What we can see is that negative 9 kilometers equals some force times 0.5 seconds for this side. Over here, on cart 2, that'd be equal to the force times 0.1 second. Okay, so if we had to get the actual force then and solve for that for cart 1, so the force on cart 1 would actually end up being negative 9.5, which equals then negative 18 newtons. Here, if we solve for that, we'll find that the force is equal to negative 90 newtons. Okay, so which cart felt the bigger impulse? Here, it's actually the same impulse, but as far as the bigger force, it was cart 2, because negative 90 newtons is larger than negative 18 as far as the absolute magnitude of that. Okay, here we've already calculated the force on each cart. So in order to give the same change in momentum, basically we have two choices. One would be we can have a big force in a small amount of time, or you can have a small force over a big amount of time. Either one will give you the same change in momentum.